Welcome back, Math 136 students, to the Module 05A problem of the week. So we're going to graph the function f by starting with the graph of y equals x squared and using transformations, which include shifting, compressing, stretching, and or reflecting, in order to graph this function, which is f of x equals negative 2x squared plus 12x minus 14. So we're going to start by finding these different transformations. Okay, to do that, we're going to start with the shifting. So the shifting really means we need to find the vertex. So the vertex of y equals x squared is on the origin, and I'm going to mark the original graph on the origin in pink. So we can see that this original graph is going to have the ordered pair of 0, comma 0 as the origin. You'll also have an ordered pair of 1, comma 1 and negative 1, comma 1. You'll also have an ordered pair of 2, comma 4 and negative 2 comma 4, and so it creates a parabola. And so what I'd like to do then is use transformations to find my final answer. Now let's again start with shifting. So as the vertex moves around in the coordinate plane, left, right, up, or down, that also represents shifting. So I need to find the vertex. To do that, I'm going to use the formula x equals opposite of b over 2a. Opposite of b would be negative 12 over 2 times negative 2, which is negative 12 over negative 4, which is equal to positive 3. So that's the x-coordinate of my vertex. Now I need to find the y-coordinate. To do that, I will have f of 3, which is equal to negative 2 times 3 quantity squared, plus 12 times 3 minus 14. Don't forget that you do need to square the 3 first before you multiply by negative 2, so it's going to be negative 2 times 9 plus 36 minus 14. Then we multiply the negative 2 and the 9 to get a product of negative 18 plus 36 minus 14. And so combining those like terms, moving left to right, we do get a result of positive 4. So we know the vertex is actually going to be at 3 comma 4. Now what I can do is actually convert this function from the general form into what's called standard form, or some actually call it vertex form. And the standard form or vertex form of this quadratic function is f of x equals a, which is negative 2. A is your negative 2 coefficient to x squared, times x minus the x-coordinate of the vertex, which is 3, quantity squared, and then plus the y-coordinate of your vertex, which is positive 4. And so this gives us all the transformations we need. Number 1, we are given the horizontal and vertical shifts, which is your vertex. And number 2, we are also given any reflections and any compressions or stretches. So let's start with our compression or stretch, and that is represented by the coefficient of 2. Now notice I'm not including the negative because the negative actually represents something else. So that coefficient of 2 means we are going to have a vertical stretch by a factor of 2. Now, if it were a fraction between 0 and 1, then it would be a vertical compression by a factor of whatever that number happens to be. But because it's 2, it is actually representing a vertical stretch. So what I'm going to do is take all of my outputs and I'm going to multiply all of my outputs by 2. My vertex is still 0, comma 0, but now my outputs for 1 will become positive 2, and then my outputs for 4 will become positive 8. And so here's my new graph. Notice I did try to color code it with the magenta or purplish type of color. And next we're going to do green, and green is going to represent a reflection. So the reflection is from the negative. So that negative actually means a reflection about the x-axis. And so I'm going to take all of my outputs, all my y-coordinates, and then change them to their opposite. Again, it actually keeps our vertex on the origin 0, comma 0. But now we have ordered pairs of positive and negative 1, and the output is going to be negative 2. So the inputs are positive 1 and negative 1, and the output is negative 2. And inputs of 2 and negative 2, but now the outputs are negative 8. And so that's what my graph looks like as it's reflected about the x-axis. Now we do have two more transformations, and we'll do both of these at the same time, and they are represented in the shifting or in the vertex, which is 3 comma 4. Because 3 is actually a positive value, it means we're going to go to the right. So we're going to shift 3 units to the right and 4 units up. Okay, so again, because it's a positive 3, it is actually 3 units to the right. Because it's a positive 4, it's 4 units up. Now, I know some people get a little bit confused because, of course, you see that you've got this negative sign right here, that x minus 3. That 3 is actually a positive value, and you can see that in the ordered pair above that line where I have the vertexes represented as 3 comma 4. So I'm going to move each and every point to the right 3 units and up 4. So 1, 2, 3 to the right. I'm sorry, I'll do this in orange. I forgot to select my color. Okay, so 1, 2, 3 to the right, and then 1, 2, 3, 4 up. So there's my new vertex. And again, that matches what I had originally, which is that the vertex is at the ordered pair of 3 comma 4. Do the same thing to all of your other ordered pairs, and so what we're going to get is those 2 points. And then finally, we will go to the right 3 units, 1, 2, 3, and up 1, 2, 3, 4 right here. And we'll have another ordered pair right there. And so connect them with a smooth curve to the best of your ability. Now in my math lab, as you answer this, most likely you're not going to have to show each and every step. I wanted to show you what you would do if you were doing this by hand. You would most likely have to find the vertex. So you'd start by selecting the vertex in the coordinate plane, and then you would need to select an additional point, and it would automatically graph the rest of the parabola. So in this case, I would select the vertex as being, let's see, that would be 3 comma 4, as we already represented. And then I would have to select an additional point, which I could choose any of those other 4 points that I have on my graph as the additional point. But again, that's really important because it determines how wide or how narrow that parabola is. And also, of course, you need to know which way it's opening, either up or down. Now, in another problem in my math lab, it does ask for concavity. And it's going to say something like, is this graph concave up or concave down? And what you need to know is that concave up means that the parabola is opening up, concave down means that the parabola is opening down. So in this case, the final answer would be concave down. And if it were opening up, it would be concave up. So just a little tidbit from a different problem. The one I copied here is not asking you for that information, but you might need to address it in a different problem. All right, guys, good luck.